Welcome! In this video presentation, we'll be showcasing the new version of CET.SteelConnDesign 1.3, along with FreeCAD for designing beam-to-column connections using end plates. Before we begin, make sure to visit our channel for instructions on how to install and set up our software with FreeCAD. If you have any questions, feel free to reach out to us at civilengrtools@gmail.com. Please note that this version does not support moment end plate connections, but they will be available in a future release. Now, let's launch FreeCAD. Once it's loaded, select the CET.SteelConnDesign workbench to start our system. You'll notice that the interface displays the new version 1.3. First, we'll create a column named C1 and a beam named B1. Next, we'll proceed to create the beam-to-column flange connection, which will be named B1_C1. In the Connection Design tab, we have the option to adjust the beam section size to our desired specifications. For instance, we can change it to a W18 by 55 section and proceed with the connection design. By default, a single plate connection is created. In the Web Connections section, we can now apply the new end plate connection. After design process, a new end plate connection is created. Additionally, an image illustrating the end plate will be displayed. This image provides explanations for several input fields such as gauge, to connection face parallel to load, edge distance parallel to load, and edge distance transverse to load. There are multiple parameters that can be adjusted in our system. For example, in the beam section, we can modify the shear load to 80 kips, and the system will automatically design a 4-row bolt configuration for the connection. By undoing the previous operation, we can observe a change to a 2-row bolt configuration. Another example is the ability to modify the number of bolt rows. We can change it to 3, but if we use the undo function, the system will revert it back to 2. It's important to mention that our system supports axial or tension load in the end plate connection. We can input a value of 25 kips for the axial load. Once the design process is complete, the plate thickness will be adjusted accordingly. Now, let's take a look at the detailed report. Since this connection involves axial load, the report will provide comprehensive checks and calculations for the bolt shear and tension interaction as well as the bolt prying action. These details will be presented in a clear and organized LaTeX format. Furthermore, the design summary section has been updated to reflect the recent modifications. Please keep in mind that support for moment end plate connections will be available in a future release. Now, let's proceed to create 2D drawings for the end plate. To do this, we will navigate to the TechDraw workbench. Our first step involves generating the drawings using the provided drawing templates. Next, we will include the right view of the end plate in the drawing. Following that, we will add the front view of the end plate to the drawing. Lastly, we will incorporate dimensions into the drawing to ensure accurate measurements. That wraps up today's demonstration. Thank you for watching.